So the space industry today is a little like a very high-speed motorway network that's been operating for about 60 years without any tow truck, right? So the situation is that today we have about we actually have more than 5,000 objects, I mean, either complete satellites or rocket bodies that are non-functional in orbit. This means that we can't actually control their trajectory. And over the last 20 years, we have been adding 74 new objects to this list every single year. And that's without counting what's happening right now in the space industry, which is going through a massive transformation, which will bring many, many more satellites into orbit, right? So the number of satellites we launch per year over the past 5 years multiplied by 16, right? Today, the figure we have here about the number of live satellites, 3,400, is already wrong. We should actually put the timer on and put the counter in so we can see as the number of satellites increases. But today, under license at the FCC, we have about 40,000 satellites. That gives you the scale of what's happening in the space industry. And it becomes really obvious that we cannot continue operating this environment the way we did in the past. To give some elements about that in a comparison to what's usually done on the ground, when you have a disaster and you have to recover a disaster on the ground, usually you count for a natural disaster, about for every dollar invested into prevention, you've got about $17 that you would have to invest into recovery. You actually save $17 for every dollar invested in prevention. In space, it's much worse. And it's much worse because every time there's a collision event, there's a fragmentation event of a satellite in orbit, then we generate a massive field of debris, which will be extremely difficult to remove, and which will make those orbits where those objects are very difficult to operate. And there's already some orbits where we can see issues where there's cascading effects. So the good news, though, is, well, first, one element you can see on this chart is is a group of objects, the defunct objects, where they are in terms of inclination and altitude, right? On the left-hand side, you can see how long a defunct object remains in orbit when it's in a specific altitude. So if you're around 500 kilometers, it's about 5 years, right? If you're at 700 kilometers, 100 years. And if you're above 1,000 kilometers, you're going to stay for more than 1,000 years. So it's a liability that remains for an extremely long time frame. The good news is that most of the objects are grouped into clusters, which makes it possible to actually build up services where we can make multiple removals. So when we looked at the space industry, our take was, well, one part is removing those failed satellites, actually clients that need service, but there's many other verticals of service in orbit that are necessary. What we actually do here is build a missing piece, a missing building block of the space industry, the capacity to intervene and maintain in orbit, right? In the automotive industry, we have maintenance capability. In the airline industry, we've got maintenance capability. In the shipping industry, we've got maintenance capability, but we don't have it in orbit yet. So we see a lot of verticals that can be served, and it's a massive market that is to activate in the sector. So what we try to create here is just not just a company, but a new industry. What we actually built when we look at Clearspace, when we looked at the challenges we have to overcome, we decided, okay, we need to build a company that is able to provide this fleet of tow trucks or servicers in orbit. And typically what we have is integrated a set of technologies. First, we build navigation capability and autonomy based on machine learning that we can actually port onto a spacecraft in orbit. We have low-cost sensor that we have made a lot of development and still doing a lot of development under inter-Swiss grants with the CSEM, EPFL, and ETH in Zurich. We have space robotics that we integrate because you have to be able to actually pick up an object in orbit, and that's one of the big challenges that you have to address. But beyond that, we built in capabilities. One is mission and system engineering, because the way you integrate all those technology to make a spacecraft in a complete system that is able to provide the right price tag is critical. It's like you can, with a set of parts, you can build a Tesla car, or you can build a very bad electric car. The way you integrate it is fundamental. We have already an industrial team of about 20 companies working with us across Europe, and are building up our ground mission operations segment that allows us to operate that kind of services at a very low and attractive cost. And finally, we also integrate impact communication Because when you want to make a change, it's not just about mastering the technologies or the operation. It's also about bringing the message through and making sure that this becomes the new normal. So this is what we actually built into Clearspace to be able to build a fleet of reusable services to provide affordable in-orbit servicing. So today, where are we? We have 54 employees in the company at this stage. We have about 450 years of combined experience in space engineering system, with people coming from, most of our top engineers have 10, 15 years of experience in the space industry. We have offices in Switzerland, where we founded the company in Lausanne in 2018, and now 2 offices in the UK. We're looking at building another office in Europe and very likely in Germany, and then in the US early next year. We signed a contract with the European Space Agency for 86 million euros to make a first removal mission. This contract has started now. We started working on it since June 2020. So we are a little more than 1 year into this contract. And with all other additional funding that we come into this contract, we have more than 100 million non-dilutive funding that comes our way for this specific mission, where we have to contribute. It's a PPP kind of approach. We secured another mission with the UK Space Agency, where we have been selected actually for the phase 0A, where we do the first feasibility analysis and the first phase of design of the mission. We're now in the phase A, so we already went through the first milestone, and we submitted another proposal to ESA to develop servicing capability for the geostationary ring together with a large US operator that contributed to our proposal. Today, Clearspace is raising 40 million in financing rounds for beginning of next year. It's a time where we are right now where we have to scale up and grow and make sure that we're very well positioned. When we look at the future of the space industry, it's just obvious for us that we cannot operate it as we did it in the past. And there's a lot of signs that we can see in the press today that this problem that we're addressing here and the capability we're building here is a fundamental need for the future of the space industry. And it's also a responsibility for our generation. The reason what really motivates us, the founding team, and the team of engineers behind this mission, is that we believe that it's our job to address this problem today. We cannot let this problem for the next generation. We cannot live with this problem any longer. So we have to be able to address that kind of issues. So this is Clearspace. Feel free to get in touch with us for our funding raise round that we have right now. Thank you very much for your attention.
Question: once you bring the garbage down, they become collectibles, and you can make probably more money by selling it to people who want to put this in the living room or gardens.
So if we want to go there, then we have to add a heat shield for the re-entry. We actually thought about this option. The question will be on the different mission, what is the trade-off between the cost of the mission and the benefit that you get out of it. So today we didn't yet find the people that are ready to finance the heat shield.
Steve Jurgensen yesterday had lots of space collectibles in the background.
I should talk with him.
Thank you so much.
Thank you very much.